السلام عليكم سلاوتان لێبێ قوتابێت چاوگەشەکانی پۆلی دوازدەی خۆشحاڵین گەڕاینەوە لاتان بۆ تاواکردنی بابەتەکانی کیمیای پۆلی دوازدە سیستەمی ئینگلیزی ئەلحەمدولیلا ئەتوانیمان بگەینە چاپتەری چوارەم ئەوە دەرسی دووەممانە لە چاپتەری چوارەم هیوادارم گورەتان بەرزبی و بەردەوام بوو بن لەگەڵ ڤیدیۆیەکان بۆ هیوایم کەوا لایەنی کەم توانی بێتمان خزمەتێکی کەمیش بی پێشکەشی ئێوەی عزیزی. Last time I have explained the specific heat, and we've solved too many math problem questions related to the specific heat, which is symbolized by Cp, right? Okay. Today it's time for something really important. We'll get back to this in chapter 5 and in chapter 6 also, which is enthalpy of reaction and enthalpy change. Very good. We have two closed terms which are enthalpy of reaction and enthalpy change. First of all, the term of enthalpy. Enthalpy, it means something like a heat. Okay? It's heat. H-E-A-T, heat. Okay? Enthalpy of reaction, it means the amount of energy transferred during a chemical reaction. Enthalpy of reaction, this term, it's specific for the chemical reaction. But enthalpy change, it's for any process at constant pressure. The process can be chemical reaction or physical change. Okay? تماشا. بابا جوانی و پێناسێت لەبۆ باس بکەم. سیرکە بزانم. Enthalpy of reaction is symbolized by delta H. Enthalpy change is also symbolized by delta H. So what's the difference between them? My dear, look. Enthalpy of reactions here. دەڵێما مستەوە تایبەتە بە reaction. تایبەتە بە reaction. It's specific for the chemical change. Okay? Got it? Okay, enthalpy of reaction, it's for a chemical reaction. But enthalpy change delta H, it's for any process. It's for any process at constant pressure. The process can be physical or chemical change. Good. Look, delta H is measured by kilojoule or joule based on the question. The standard condition we call standard temperature, STP, standard temperature, which is 25 Celsius degree, and pressure, which is 1 atm. Good. Nice? Of course, we have something that cannot be calculated directly, which is called H. What is the name of H? H is enthalpy alone. Enthalpy cannot be measured directly because there is no proper way to measure H directly. It's not a practical way. أما لكردواري خمان دلين على كاك فلان موبايل كودر أو موبايل ولا إيش دكا بس عملينية it means it's not a practical. عملينية يعني إيش دكا بلام زوتك دتي زور بكلجنا. The same thing is true here. But delta H can be measured directly. Good. You know what I mean by this question. Let's solve these two questions. What is the quantity of energy absorbed or released? Look at it. What is the quantity of energy absorbed or released? Instead of this, I can say that transferred as heat during a chemical reaction. Chemical reaction, if we have a chemical reaction, so the amount of energy that is transferred must be enthalpy of reaction, which is symbolized by delta H, right? And look at this. Heat of formation, this is delta HF. Heat of combustion, delta HC. Entropy is S. Entropy change, delta S. Enthalpy of reaction is delta H. Look, please, my dear. Heat of formation, enthalpy of formation. Delta HF, delta HF. Enthalpy of combustion, delta HC. and entropy is entropy changes معناها ايش بيقدر delta is enthalpy of reaction is delta H. So which one is the enthalpy of is the amount of energy that is transferred during a chemical reaction is enthalpy of reaction. It's easy. Okay, another one. Which of the following cannot be measured directly? Look. All the values with delta can be measured directly, but the one without delta, which is H, cannot be measured. Look at it. Heat of formation, delta HF. Yes, it's directly a directly measurable value. We can measure this directly. Heat of combustion is delta HC. Enthalpy change is delta H. Enthalpy alone is H. Which one cannot be measured directly? This, yep. This one, yeah, can be measured directly. Both can be. It's possible to measure them directly. This one also. This one cannot be measured directly. So will be the correct answer. This is the correct answer. Let's move up. What factor influences value of delta H? So delta H of any system can be influenced by some factor, and also it has a resistance against some factor else, right? So we have two factors that are affect the value of delta H. The factors are, the first one, the change in the number of bonds. Look, change in the number of bonds. If the bond is double or triple or single, it has effect on the value of delta H. Be careful. And the strength of the bond. If the bond is weaker or stronger, it depends on the atomic size, which is not included in this book. Good? So there are two factors that are influence the value of delta H. The first one, number of the bonds. Number of the bonds, please. And the second one, strength of the bond. If the bond is weaker or stronger. او رزوله هذا كمان يا باشا او حركه كريستيانو رونالدو يا ديمو اوبري بابي من اس ديمو اوبري سبركم لي بقرا ديمو ورا افريم. So now we have two graphs. We have two energy curves. One it's for the exothermic reaction, the other one will be for the endothermic. So I'm going to explain the whole features and details with one of them. For the other, the rest of the points will be reversed, will be opposite. Exothermic reaction, man. Here. Look, I'm trying to draw the picture from the first. Look at it. So we have energy axis with the course of reaction or reaction pathway. We have energy here. Energy and course of reaction or reaction pathway. Good. Look, we have reactant and product. Reactant and product. It's okay to have reactants at higher energy level, product at lower, or reactant at lower energy level and product at the higher energy level. I'm going to start with the one that has reactant at the lower energy level here, and the product is here. Look, my dear, this is reactant, and this is product. Very good. So conversion of reactant from a lower energy level to the higher energy level. Let's compare their energy levels. First of all, energy of product is greater than the energy of reactant. Energy of product is greater than the energy of the reactant. Good. It means reactant has absorbed an amount of energy to approach here. This is called endothermic. Endothermic. Endo باندومي ببيرد بيتوا. رياكتان اندومي خواردي حتى تزيشي برس وزي زوربه ولو اندومي بيران دكاتسو وزدنا داتي اندومي بس او تزيلي هم حزين لا اندومي reactant endothermic endo خواردی ها اندومی خواردی ها تزيشي برس energy زيادة. So this reaction is called endothermic. Endothermic. Okay, this is endothermic reaction. If the reaction is endothermic, the value of delta H must be positive because delta H equals to H final minus H initial, or H of product minus H of reactant. Look, since the energy level of product is greater than the energy level of reactant, so we will subtract a greater number by a smaller number. Big greater number minus smaller number results a positive value. Good? So it's like a pebble in our reaction exoya and indoya, the lemstero indoya. Ele indoitsona the energy product, the energy reactant. How about this? This is called amount of energy that has absorbed or that has been absorbed by the reactant. Absorbed. So the difference between energy levels of product and reactant is called delta H. It must be positive. It must be what? Positive. Mr. Esta Amazani man, endothermic reactanti nevia, reactant energy camtrela product. Our pedalan endothermic reactant indomi da khwa indo و زي زور ده بیده تا product. تگشتن کو؟ باشه ببینیم. Delta H man da BCB positive. There's one more thing. How about the stability? What is the relation between the energy and the stability? أنا في كل لما ندارة شو كولا ما عليهم أنا من دارة شو قيس كبابلين قاوي زور خواردي هني. Think about a small child, okay? كقاوي شي زوري خواردي. ما دام قاوي زور خواردي بي, so he needs to have more energy, right? طبعا داری كله قوي خواردی نانوی هتا درنجی شده ها انرژی زور نانوی stable unstable و یا نان reactive زور دبینی ساعت 12 شو مدال دانانشی دست سر سلاتی دست سر پانکی دست سر دیواری لهم زیش هر دپاری دیت سر هر دپاری دانانشی وقتا چی دبینی دنجی نما تمشاهده که لشوی نشی نوستیه انرژی نما stable بو انرژی کم بیتو stable بو دلی ما مستیانی تاو که انرژی کم ببی stable دبی look at this. Reactant has less energy, so it must be more stable compared to the product. Because product has a greater energy compared to the reactant, so it must be less stable. Less stable. And since the reactant has less energy, it must be more stable. So what's the relation between the stability? Stability is inversely proportional with the energy. As the amount of energy is increased, stability is decreased. It's like this. Good? Look. So now for this reaction. Okay. CO2 to form carbon and O2. Delta H equals to positive 393 kilojoule. Tell me, which one is more stable, reactant or product? كعمل stable ترى, reactant or product? Just wait. Look, since the arithmetic sign of delta H is positive, that means the reaction is endothermic. Is what? Mister, for the endothermic, reactant is more stable. Yani CO2 is more stable compared to carbon and oxygen. Great. I feel a woman. طابو او باسويناك مو هم لبو باسكرين بزدي طاقة من باسوي بك مو زو بتزاينو باسكرين now endothermica reactant layer product layer. So let's see, reactant is more stable than the product because it has less energy. This will be the amount of energy that has been absorbed, of course, okay? And this is delta H. It must be positive course of reaction energy. For the exothermic, exactly will be opposite. Get. Apem goti de garemo para pieshkhoy. Where garemo para pieshkhoy. Delta H equals to H of product or H of final minus H of initial. Delta H, it can be positive and negative. If it's positive, the reaction is called endothermic. But if it's negative, this must be exothermic. Good? That's all. If H of reactant is greater than the H of product, the reaction must be exo, and opposite. If H of product is greater than the H of reactant, the reaction must be endo. In this case, reactant is more stable. Look at it. More stable. And this one, product, is more stable. Done. It's easy. Serious, let me explain this. For this reaction, the combination of hydrogen and oxygen gases to produce 2 water molecules, delta H is negative 484 kilojoules. The quantity of energy released as heat here in this, okay, or any other reaction depends on the amount of reactant and products. It means the amount of reactant. Look at this. You should know, my dear, amount in the reaction stands for what? Stands for the number of mole. Number of mole, it means coefficient. Okay? It means if I double the coefficients, the amount of energy must be doubled. If I decrease the coefficients into half, the amount of the energy of reaction must be decreased to half. Okay? Good. The quantity of energy as heat released as an explosion. So the amount of energy is released as an explosion during the formation of water molecule H2 and O2 is proportional to the quantity of water formed. It means if I double this, example, if I change this coefficient to 4, it means if I multiply this by 2, this one must be multiplied by 2. If I divide this by 2, this must be divided by 2 also. Good. Keep going. On and basket. Farim. Acidinera. Thermochemical equation. What is the thermochemical equation? Very important, mainly for chapter 6. This is very important, mainly for chapter 6. And for this chapter, of course. What is the thermochemical equation? Let's have some examples. Think about this reaction. Carbon plus O2 to form CO2 plus 393 kilojoules. And we have another reaction, O2 to form CO2. Delta H equals to negative 393. Vamos a ler ao kilojoule. Okay. Our reaction here, we have some numbers inside of the reaction with the unit of kilojoule. But here, the amount of kilojoule is from the outside of the reaction. Look, once we have a kilojoule or number inside of the reaction, without waiting, just say, Mr. Look, this is delta H. Another equation. Look, A plus B plus 100 kilojoules to form 3C. Again, we have some numbers inside of the equation. It means this is delta H. كواتا اگر کیلوجول معناها بو باقشتی و با قليله ناو equation بو داریم ما مساوي يكسر دلتا H. تيا دلتا H. Energy of reaction, heat of reaction. Now I'm gonna write the whole names for delta H. Stay with me. Stay focused, please. Mister, if the amount of kilojoule is written, if the amount of kilojoule came with the product, this is called exothermic. But if the amount of energy came with the reactants, it must be endothermic. Endothermic. It must be what? Endothermic. So let's have this example. Carbon plus O2 to form CO2 plus 393 kilojoules. Okay, since the amount of energy it came from the product side, so this is exothermic, and it's a value of delta H, which is 393 kilojoule, but because it's exothermic, so we need to add negative. But why here it has a positive sign? My dear, inside of the chemical equations, there must be always plus sign between any two things. اوكي يعني لبيني هردو اشتكاتك equation ده نسين ده بيتيانا بيني بي plus يانا بيني بي. But once we take out the value of delta H, then if it's at the product side, we will add negative. If it's at the reactant side, we will add positive. Another example. بونمونا A plus B plus 20 kilojoules to form D. What is this inside of the reaction? This is delta H, and its endothermic must be positive. The amount is 20 kilojoules. Good. Another example. So now, assume we have this reaction. Carbon plus O2 to form CO2. Delta H equals to negative 393 kilojoules. Get. Try to, this is not, this kind of reaction is called, this kind of equation is called thermochemical equation. أول شيء بدلن thermochemical equation. What mean by the thermochemical equation? An equation that has the amount of energy transferred as written with the products or reactants. If it came with the products, the reaction or the process must be exo. But if it came with the reactants, the process must be endothermic. Must be endo. اللي ما مثلا thermochemical equation أوعى delta H there. أجر delta H كلا product تبو or delta exo. But if it's at the reactant side, it must be endothermic. Esther, this is not a thermochemical equation. Try to rewrite this, but this time in the form of thermochemical equation. يعني وراء delta H بخناو reaction. That's the كاملة. Look at this. This is a negative value, which is exo. Which is what? Exo. Good. Exo, it must be written at the product side. Carbon plus O2 to form CO2 minus 393 kilojoule. Asana, Babi, low negative. But Mr. Here we have the negative sign. No. Once it enters to any reaction, the thing that needs to be present between any two variables is plus sign. So we will add the numbers by plus sign into the equation, okay? We don't use negative sign in any equation, chemical equation, of course. Good. Thermochemical equation, an equation that includes the quantity of energy released or absorbed. Quantity of energy released or absorbed, it means delta H. As seen during the chemical reaction as written. Look at it, if the amount of kilojoule locates at the reactant side, it means this is endo. But if it's at the product side, it means exo. Good. Look, rewrite each equation below with the delta H value including as in either reactant or product. It means we have some questions. 1, 2, 3. Rewrite each of the following equations, but this time in the form of thermochemical equation. In the form of thermochemical, mashallah. In the form of thermochemical equation. Look. This is negative, so it needs to be added for the products, right? Write the equation again from the first. 2CO2 plus by O2 to form 2, sorry, this is not CO, this is SO2, of course. 2SO3 plus, لبروي negative هذا بيستر product. نبيتها plus 197 kilojoules. Good. How about this? Since the value is positive, it must be here. Anyway, lady, هذا بيتها 2NO2 plus 114 kilojoules to form 2NO plus O2. This is a negative value, must be here. Plus, rewrite the whole equation, but this time add the amount of kilojoule to the products. Good enough. We'll get back to these notes during solving questions. Inshallah, next lesson we'll get back to this. Just wait for this. Wait. There's this point which is really nice. Look, the value of delta H, okay, is independent to the temperature. It means as the amount of temperature is changing, the value of delta H cannot be changed. Good? Cannot be changed. أو نوتانا بيم وتن درسي رابردو يعني بقول درسي دابي إن شاء الله ديما سري. طبعا بسيارة شي لقى أكيد. شبابي من عندك شو تيبي جوي بردام بمن سري. باعونا ونتفيقلهم. Delta H has the following names. Okay, write the names for delta H. The first one, I'm gonna say the names. You have to write the names. You will see delta H in the questions by the following names. The first one, enthalpy change. Enthalpy change. First one. Second one, enthalpy of reaction. Enthalpy of reaction. Enthalpy change. Enthalpy of reaction. Another one, energy of reaction. Energy of reaction. Another one, heat of reaction. Heat of reaction. صار نيمي هي نيمة شكشية لكات خوي وري دقري. Enthalpy change, enthalpy of reaction, energy of reaction, heat of reaction. These are the 4 names for delta H. Write them down inshallah and try to memorize the whole names. Inshallah درسي ده بباسي delta H افتان لبودا كم لقى delta HC. Stay focused so that lesson will be very important. Okay? You are there مني تيجي يشتمن تاواني ده هاتو بخواتان دسبيرم خواتان لقى العزيزة كان